You've probably seen a version of this headline before. Elon Musk announces a motor that needs no rare earth elements, and it's going to shake the entire EV industry. It sounds like breaking news. It isn't. That announcement happened in March 2023. What you're looking at now is old news being repackaged as new, and the reason that keeps happening is actually more interesting than if it were true. Because the real question isn't whether Tesla said this. It's why, 3 years later, a car that runs on this motor still doesn't exist. Answering that question tells you something bigger about how modern companies make promises and how fragile the entire EV and robotics supply chain really is. Start with what rare earth elements actually do, because the term gets thrown around without explanation. Elements like neodymium, dysprosium, and terbium are used to make extremely strong permanent magnets. Inside an electric motor, those magnets are what let the rotor spin efficiently without needing a constant, wasteful electrical current to create a magnetic field. Tesla's most efficient motors, the ones used since the Model 3 arrived in 2017, rely on this kind of magnet. It's a major reason those cars get the range and efficiency they do. The problem is where those elements come from. A large majority of global rare earth mining and processing happens in China, and the extraction process is genuinely dirty. It produces toxic byproducts and has real environmental and health costs. So when a Tesla executive stood on stage and said the company's next drive unit would use a permanent magnet motor with zero rare earth content, it sounded like an elegant fix to a dirty, geopolitically risky problem. Good for the environment, good for supply chain independence, good for cost. That's the version everyone remembers. Here's what gets left out. The executive who said it, Colin Campbell, Tesla's director of powertrain engineering at the time, wasn't describing a finished product. He was describing a design intention for a future drive unit. And almost immediately, materials physicists pushed back, not because they doubted Tesla's ambition, but because they doubted the physics. Researchers at the University of Delaware and Uppsala University in Sweden both said, in separate interviews shortly after the announcement, that they were skeptical any known non-rare earth material could deliver the magnetic strength a compact, efficient traction motor needs. That's not a minor technical footnote. It means Tesla announced a solution to a problem that some of the world's leading experts in magnetism weren't sure was solvable yet. So why announce it at all, years before it's ready? This is where the incentive structure matters more than the engineering. Investor Day presentations exist to shape how markets, suppliers, and regulators think about a company's future, not necessarily to report what's already built. Tesla had already reduced rare earth content in its Model 3 and Model Y drive units by 25% between 2017 and 2022 without sacrificing efficiency. Framing zero as the next logical step made a genuine engineering trend sound like an already solved problem. The claim did real work for Tesla's story. It just ran ahead of Tesla's factories. Now here's the detail that makes this whole story worth revisiting today. As of early 2026, no rare earth-free Tesla drive unit has appeared in any production vehicle, supplier filing, or investor disclosure. The 2023 promise is still, by every available public record, aspirational. That alone might just read as a delayed product. But it's not the interesting part. The interesting part is what forced Tesla to admit out loud that it still depends on rare earth magnets right now. And it wasn't a car. It was a robot. In 2025, China tightened export controls on rare earth magnets, the same materials used in high-performance motors. Elon Musk acknowledged that these controls disrupted production of Optimus, Tesla's humanoid robot program. Think about what that admission actually reveals. Tesla had spent 2 years publicly signaling that it was moving away from rare earth dependence. And the moment a real geopolitical lever got pulled, the part of Tesla's business that got hit hardest wasn't the cars everyone associates with the original announcement. It was the robotics division nobody was watching for this exact vulnerability. The visible promise was about motors in cars. The real exposure turned out to be magnets in robots. That's the chain reaction worth tracing all the way through. An ambitious announcement in 2023 generates headlines and investor confidence. Expert skepticism gets buried under the excitement because skepticism doesn't trend the way bold claims do. Years pass with no shipped product, but also no correction. The claim simply stops being scrutinized. Then, in 2025, an external shock, China's export controls, exposes that the underlying dependency never actually went away. And the consequence lands somewhere the original story never mentioned, a robotics program, at a moment when humanoid robots are being pitched as one of the largest new markets for the entire industry, worth tens of billions of dollars by the mid-2030s in some projections. A supply chain vulnerability that looked solved on a stage in 2023 turned out to be very much unsolved in a factory in 2025. To be fair to Tesla, it isn't alone, and it isn't obviously behind. This is a genuinely industry-wide race, and looking at where competitors stand puts Tesla's claim in perspective rather than singling it out. General Motors and Stellantis have both invested in Naira Magnetics, a startup developing iron nitride magnets as a rare earth alternative, with a joint development effort specifically targeting traction motors. Valeo, working with Renault, is reportedly aiming for real production by 2027. Vitesco has said its own rare earth-reduced motor could reach market as early as 2026. German supplier ZF has an experimental design that swaps magnets entirely for electromagnets in both the rotor and stator. None of these programs have fully arrived either. The honest industry consensus reported across multiple outlets is a staggered rollout, early, limited adoption starting around 2025, moderate-scale launches between 2026 and 2028, and broad mainstream availability sometime in the early 2030s, not this year, and not because one company announced it first. That framing changes how you should read the original headline. The realistic optimistic outcome is that Tesla, GM, Stellantis, Renault, and others gradually phase rare earths out of traction motors over the rest of this decade, easing a real environmental and geopolitical problem without a major performance penalty. The realistic negative outcome is closer to what's already happening. Announcements outrun manufacturing reality. Dependency on Chinese control materials continues quietly in the background, and it takes an external shock, like an export restriction, to reveal how little has actually changed. The failure scenario, still on the table according to some of the physicists who raised early doubts, is that no material or motor architecture ever fully matches the performance of rare earth magnets in a compact vehicle motor, and rare earth free ends up meaning rare earth reduced for a very long time, if not indefinitely. So what is this story actually about, once you strip away the headline? It isn't really about a specific motor, and it was never really a story about Tesla beating an engineering problem. It's about the gap between announcing a solution and manufacturing one, and about how that gap can stay invisible for years until something outside the company's control forces it into view. Tesla said the words zero rare earth elements in 2023. Reality answered in 2025 through a robot that couldn't get built the way it was supposed to. The next time a headline promises that one motor will shake an entire industry, the more useful question isn't whether the claim sounds impressive. It's whether anyone has checked what's actually rolling off the production line.